This is question 2 from the MTH312 Midterm of the fall 2024 semester. And so this question is asking, find the Laplace transform of f of t, which is the integral from t to 0 of tau sine 2 tau d tau. And we want to find the Laplace transform without evaluating the integral prior to calculating the transform. So we want to solve this without integrating. Well, what is the first thing we can do? Well, we can obviously write our Laplace. So our Laplace of the integral from t to 0 tau sine 2 tau d tau. So this is what we are trying to find. Now, there is a theorem, and this theorem essentially tells us that if we take the Laplace of the integral of t of 0 of f of tau d tau, this theorem tells us that the Laplace of this is going to be equal to 1 over s times f of s. So, knowing this would essentially represent our f of t, meaning that if we know f of t and we are able to find f of s from f of t, then all we would have to do to find the Laplace of this would just be multiply a 1 over s to the capital F of s. So let's go ahead and do that. We want to find the Laplace of f of t, which will give us capital F of s. So then, if this is f of t, let's go ahead and try to find Laplace of f of t. For tau, we can just replace the tau with t. So we have t sine 2 t. Now, how would we find the Laplace of this? Well, there is another theorem, and this theorem states that the Laplace of t to the power of n being a number 1, 2, 3, 4, and so forth, times a function f of t, this would be equal to negative 1 to the power of n, capital F to the power of n, s, where n obviously, in this case for here, would represent the derivative. And so we can apply this because we know that for f of t, we have a t here, and our n here is equal to 1. And then our f of t in this case would be the sine 2t. So if we can find the Laplace of sine 2t, then this will give us f times s. Now, since we know that n is equal to 1, we would have to then differentiate our capital F of s that we find from f of t of sine 2t. So essentially, the Laplace of sine 2t is equal to, or well, let's evaluate this together. So we know that this would be negative 1 to the power of 1, which is just negative 1, times, what is sine 2t? Sine 2t is just 2 s squared plus 4, 2 over 4. We differentiate this. So if we differentiate this, then we'll have negative 1 times, I'm just going to skip through the differentiation. If you differentiate it correctly, you should get 4s s squared plus 4 squared, and we get negative 4s s squared plus 4 squared. So after finding the Laplace of t sine 2t, we should get negative 4s over s squared plus 4 squared. Now what is this? What we just found is the f of s that we were looking for in the first theorem that I highlighted. So all we have to do now is multiply a 1 over s to our f of s, and we should have our answer. Oh, and this should be actually, when we differentiate, this should give us a negative 4, meaning the negatives cancel out. So now the Laplace of the integral from t to 0 of tau sine 2 tau d tau is going to be equal to 1 over s times f of s and so we can see that this s will cancel out with that to leave us with our answer of 4 over s squared plus 4 all squared. So this would be the answer.